Here we have three numbers, a1, a2, and 3, which represent three consecutive terms of a geometric sequence. The next thing, we're going to subtract 4 from the last number, and we get three consecutive terms of arithmetic sequence. The next thing we're going to do, we're going to subtract 1 from both second term and the third term of this arithmetic sequence. And we're going to get back to geometric sequence. And the question that's being asked is, what are those three numbers in the original geometric sequence? We're going to solve this problem by using the definitions of geometric and arithmetic sequences. First, we start with the top geometric sequence. So as we know, geometric sequence is the sequence where every next term is obtained from the previous term by multiplying it by the same factor. In this case, we're going to call this factor q. So a2 is obtained from a1 by multiplying a1 by q. Same way, 3 is obtained from a2 by multiplying by the same factor q. In a similar way, we're going to deal with the second geometric sequence. And the factor in this sequence we're going to denote as b, because potentially it could be different from this q. And the last thing, let's deal with arithmetic sequence. And arithmetic sequence, by definition, is a sequence where every next term is obtained from the previous term by adding a specific number. In this case, we're going to call this number d. So first of all, let's look what we have. We have 6 equations, and we have actually 6 unknowns. So probably we can solve this problem and find all values for a1, a2, a3, and q, b, and d. Notice that we don't really need q, b, and d. All we need is a1, a2, and a3. So the first thing we're going to do is we're going to concentrate on the first two equations representing the first geometric sequence. What we're going to do, we're going to divide the second equation by the first one. In this case, q going to go away, and we get a relationship between a1, a2, and a3. So let's rearrange it. What we're going to do, we're going to multiply both parts of this equation by a1 and a2. And we're going to have this expression that says that the second term squared is the product of the first term and the third term. We can use this expression for the second geometric sequence. In the same way, the second term squared is going to be the product of the first term and the third term of that geometric sequence. Now we're going to open up the parentheses. And the next thing we're going to do, we're going to subtract this equation from this equation. In this case, the term a2 squared and term a1, a3 going to cancel out. And the remaining terms we're going to rearrange so we can express a2 via a1. Now what we're going to do, we're going to look at this equation for arithmetic sequence. And this equation can give us the value for d. So we see that d is a2 minus a1. If we substitute this expression for a2, we get expression for d via a1. And now we're going to substitute this expression for a2 and this expression for d into this equation. And we get expression for a3 via a1. So what we have now, we have a2 expressed through a1 and a3 expressed through a1. And now we're going to plug those values into this equation for geometric sequence. If we do, that's what we get. We can open the parentheses. We get expression like this. Now we're going to combine all like terms. We get quadratic equation for a1. We're going to multiply this equation by 4. Just we get equation like this. We don't have to do it, but just nicer looking equation. So, and now we just solve this quadratic equation. To remind you, if I have the quadratic equation ax squared plus bx plus c equals to 0, where a, b, and c are constants, This equation has two roots, two solutions that we can obtain using this formula. So in our case, A1 plays the role of x, 9 is A, minus 10 will be B, and 1 will be C. If we plug these values into this expression, we get two real values for A1, and A1 could be either 1 or 1/9. And now we just simply substitute both values for A1 in this formula for A2 and this formula for A3, and we get two solutions. One solution is 1/3 9, and the other solution is 1/9, 7/9, and 49/9.